In this video, we're going to look at graphing a piecewise-defined function. So number 12, find the domain and range of the function. First thing I want to do is I want to graph them. So what I'm going to do is I'm going to take our first one, this 1/6 x. So 1/6 x, and I'm going to create an xy chart. Fortunately, these are linear functions, so I really only need 2 points to graph these. I do need to be careful of what my limitations are. So for this one, my x values are less than 0. So I can use 0 as a point, but I just have to be careful when I'm graphing it. So I'm going to use 0, and what I'm doing is I'm taking these values here, plugging them into my x, and I'll find my y value. So 1/6 times 0 would just be 0. And then I'm going to pick a second number. This I definitely need to make sure is less than 0, because again, my limitation here is my x values have to be less than 0. I'm going to avoid fractions, so I'm going to use -6, because if I do 1/6 times -6, that's going to give me -6/6, which is -1. Okay, so there's different ways to find those points or to graph this, but that's the way I'm choosing for this specific problem. And then those points I'm going to graph. So -6, -1 is going to be right about here. And then 0, 0, be careful. 0, 0 is not included on the line. It goes up to it, so we're going to put an open circle. All right, reason for an open circle, again, because there's less than 0, but not equal to it. So that's think of that as our boundary. And then I'm going to continue this line all the way over. It's close enough, not perfect, but you get the idea. Since my x values are less than 0, it's going to continue going off to the left. So now I'm going to take a look at the second equation. I'm going to look at x plus 1. So again, I'm going to create an xy chart. And this is for numbers that are greater than or equal to 0. So I do want to know what 0 is, so I'm going to use that. Oops. I'm going to use that 0. And this time, these x values here are going to get plugged into that equation. So 0 plus 1 would just be 1. And then I can pick any number I want that's greater than 0. So I can use 1, 2, 3, 4. It doesn't really matter in this case. I'm just going to pick the number 3, so it's off to the side a little bit. So 3 plus 1 gives me 4. So if I use an x value of 3, my y value would be 4. So if I graph this, I'm going to plot those points. So I'd have 3, 4 right there, and then 0, 1. Now this time it is equal, greater than or equal to 0. So I am going to put a closed circle. And then this covers all values greater than or equal to 0. So I'm going to keep that arrow going all the way up to the right. Now we want to look at domain and range. So my domain being my x values, right? And I'm going to write these in interval notation. Now x, the first one, the one we kind of worked with in blue, that covers everything that's less than 0 for my x values. And then the red one covers everything from 0 greater than that, all the way up to positive infinity. So the blue one covers negative infinity all the way up to 0, or to the boundary of 0, and the red one includes 0 and works up to positive infinity. So what that tells me is that I can use anything for my x values. Everything is covered between the two equations. So I'm going to say negative infinity to positive infinity. Now for my range, what I do want to be careful of here when looking at my y values, I notice that right in the middle, right around here, right, there's a gap in my y values. There's no y value between 0 and 1. Right, doesn't work there. So what's going to happen is I'm going to look for the range of the blue one, which this graph keeps going down forever. So that's going to be negative infinity. And then it goes all the way up to 0. But 0 is not included. It's just that boundary. So we're going to put a parenthesis. So that covers that blue one is going to be negative infinity to 0 for my y values. The red one starts at 1. 1 is included, so we can put a bracket there. And it keeps going up forever, so that's going to go up to positive infinity. Now, since I have these two parts of my range, what I'm going to do is I want to include both of them. Use like a capital U symbol, and that's going to represent the union between those two interval notations. So it counts the blue one and the red one, and that, let's highlight this. So this would be my range, and that would be my domain. We're going to skip number 13 and jump to number 16. So we're looking to graph the following function. Oh, that should say function. And they give us 3 different pieces in this time. So what I want to do is I'm going to graph them as best I can on this graph here, and I'm going to do them in parts. What I like to try and do is I try to focus on the constant one first. So this -1 is constant from -4 to 5. Right? So at -4, it's always going to be -1. So -4, -1 is going to be right here. And I'm going to put an open circle because it's not equal to it. And then this is going to go all the way up to 5. And again, we have an open circle. For that entire piece, it's always -1. So any value from -4 through 5 is going to be -1. So those are all coordinate points if you're trying to graph them. So I'm going to highlight that so we can match that up. Now, my next equation, I'm just going to go in order now. So this x plus 2 is for everything that's less than -4. So I'm going to use x plus 2, and that is x is less than or equal to -4. So I'm going to create an xy chart. I'm going to use -4 because it is included, and then I can pick anything less than that. So just to make my life easy, I'm going to use -5. If I take this -4 and this -5, wrong one, this -4 and -5, and I plug them in as my x values, I'm going to get -4 plus 2 and -5 plus 2. So that's going to give me -2 and -3. And these will give me 2 points I can use in my graph. So -4, -2 would be right here. Didn't want to erase that. I'm going to put a closed circle because it's equal to -4. And then -5, -3 would be right here. And then this is for everything below that. So that's going to keep going to the left there. All right, again, not drawn perfectly straight, but you get the idea. Now, -1/5 x, oh, sorry, not negative, +1/5 x, is for everything where x is greater than or equal to 5. So same idea. I'm going to create an xy chart. It's just a line, so I can use 2 points. I only need 2 points to get that line. I'm going to use the number 5, and because I have fractions, I'm going to try and make my life easier. I'm going to use a 10. So 1/5 times 5 would be equal to 1, and 1/5 times 10 would be equal to 2. So this is going to be 1, 2. And these numbers, again, are being plugged in here, and that's where I'm getting those values. So let's plot this point, 5, 1. That's going to be here. Closed circle, because it is equal to 5. And then this is going to go from to 10, 2, which would be here. And that's going to continue for all the numbers that are greater. So we're going to put an arrow there. That's going to represent that piece. And what did we do? We did that in green. So let's highlight that. And now we have the graph for that function. So the main idea behind this is you have to be careful what your limitations are. So you need to look at these pieces here, and that's going to determine your values. Use a chart, an XY chart, to get the coordinate points for each piece, and then you can just graph them and plot the rest of the graph from there. All right, number 11, find the domain and range of the function whose graph is shown. Okay, so domain and range. I need to look at a bunch of x values and y values. So let's see what's going on here. So x values, I'm going to start on the left and I'm going to work my way right. So I see that I have an x value starting at what looks like -7. This is going to continue to -4, and at -4, this counts, so we're still working, even though the -4 here is a open circle, it's closed at that -4. Down below, we're at -4 and -7. It's going to continue to what looks like 1. All right, so we're going to continue here. Then there's going to be a gap, and it's going to start up again at 2. And then it continues continuously to, what is this, 8. All right, so it's going to match up at 8. So my domain values, it looks like we're going to go from -7, and that's going to continue up to 1, closed circle, so that means a bracket. There's going to be a gap, and then it's going to pick back up at 2, and then work its way up to 8. All right, so we have that. And then since we're joining those, we're going to talk about the union between them like we did in the previous problem, 2 problems ago. Now my range, right, we're looking at y values now. So my lowest y value is going to be right here. Let's not use those dots like that. The lowest y value looks like -7. We're good continuing up through this graph. All right, so we're still good here. Something's being covered with my y range. There is a little jump here, but it's still covered over here. So we're still good moving forward, and then it's going to increase all the way up to this point there. Now I know that looks a little tricky or confusing, but you're just looking for the lowest and the highest y values and making sure there's no gaps in between. So my lowest value for my range is -7. It's a closed circle, and then it goes all the way up to 9, again a closed circle. So we're going to put a bracket. Just be careful with gaps, all right? If you're looking at these, and like we noticed, there was that gap right in here. There was no x value that matched up between 1 and 2. There was nothing in that middle there. So if you're careful with that, you shouldn't have much of a problem with those.